Hey guys, and today I'll be talking all about redox reactions in chemistry. So to start off, what even is a redox reaction? And if we look at the word redox, we can separate it into two different parts, the reed and the ox. The reed refers to reduction, and the ox refers to oxidation. And what this means is that in a redox reaction, both oxidation and reduction take place at the same time. So there's time, that's important. One can't happen without the other. But what does reduction or oxidation mean? Well, oxidation is pretty easy to guess. That's when something gains oxygen, right? It gets oxidized. And reduction is on the opposite, is when something has a loss of oxygen, right? So these are our basic definitions. A redox reaction is when reduction and oxidation happen, and they happen at the same time. And in oxidation, there's a gain of oxygen, and in a reduction, there's a loss of oxygen. So, for example, we can look at, we have iron oxide, plus carbon monoxide that turns into iron plus carbon dioxide. Now, I want you to figure out what is getting reduced and what is getting oxidized. Alright, so I hope you did this by yourself and then came back to check your answer. So here we can see that iron loses oxygen, and that means that it gets reduced. On the other hand, we can see that carbon gains oxygen. That means that it gets oxidized. Alright, that was pretty simple. Now, in a redox reaction, there is a concept or a definition such as an oxidizing agent and a reducing agent, to which I will get in just a second. So an oxidizing agent is a substance which oxidizes the other substance. So, now the other part right here, that's very important because unlike the name may suggest, the oxidizing agent itself gets reduced. And this is, as we can tell, it oxidizes the other substance, meaning that what can it be left with? Oh, but it has to be reduced. So what is the reducing agent then? Well, that's just the opposite. That's a substance that reduces the other. So what does that mean for itself? Well, that means that it gets oxidized. If the substance reduces the other, which causes a loss of oxygen, that means that the substance itself gains oxygen, so it gets oxidized. So going back to our example over here, I encourage you to figure out for yourself what here is the reducing agent and what here is the oxidizing agent. Alright, so once again, the oxidizing agent is what oxidizes the other substance, so it gets reduced itself. And here we can see that that's what iron does. Iron is the oxidizing agent for carbon. On the other hand, the reducing agent is what reduces the other substance. And here, iron is reduced and carbon gains the oxygen. That means that carbon is the reducing agent. Alright, so this was really simple, and reactions like this can be spotted very easily because they have a clear oxygen. So over here, you can clearly tell that the oxygen moves from iron to carbon. But redox reactions do not always involve oxygen. And when we don't have oxygen in our reaction that is clearly being lost or gained, we look at the electrons. So basically, what oxidation is a loss of electrons. And then reduction has to be a gain of electrons. And you can remember this with oil rig. Oxidation is loss of electrons, reduction is gain of electrons. So basically, whenever a substance loses electrons, it gets oxidized. But whenever a substance gains electrons, it gets reduced. Unlike the losing or gaining suggests, because reduction and then it gains, that's a bit confusing, so don't get it confused. So let's look at two examples. Here we have chlorine plus sodium that goes into sodium chloride. So what here is getting reduced and what here is getting oxidized? Okay, so I hope you do this by yourself and check your answer. And to do this, we can look at the electron configuration. So chlorine has 7 outer electrons, and then sodium has 1 outer electron. So sodium gives chlorine that 1 outer electron. So sodium is losing electrons while chlorine is gaining electrons. And that means that sodium is getting oxidized and chlorine is getting reduced. Let's look at a second example. In the second example, what we're going to have is we're going to have chlorine plus hydrogen that goes into hydrogen chloride. And once again, find what is getting oxidized, what's getting reduced based on electron configuration, and then come back and also identify the oxidizing agent and the reducing agent. Alright, so chlorine has 7 outer electrons, while hydrogen has 1 that needs to be lost. So hydrogen gives its electron to chlorine. So what can we say? We can say that the hydrogen has a loss of electrons, thus hydrogen is getting oxidized, thus it's the reducing agent. On the other hand, chlorine is gaining electrons. That means that it got reduced. That means that it's the oxidizing agent of the reaction. Alright, so that was it for redox reactions for today, and I hope you understand what it means to have redox with oxygen and what it means to have redox without the oxygen. And remember, oil rig, just in case. And I hope you enjoyed.